All right, so let's get started. Welcome, everybody. It's my pleasure to announce our next big Tech Day talk titled Migrating a Security-First Application to an In-House Cloud. Today we have the privilege of hearing from 3 distinguished experts who will share their journey of migrating the platform Idgard to a modern stack. But first, let me introduce these experts. Our first speaker is Sebastian Eder, who is the CTO of Uniscon, where he leads the development department both on a personnel and a technical level. He is deeply involved with cloud technologies, particularly focusing on security. Previously, he worked as CTO and CEO at his self-founded company Qualicen in the field of AI and NLP, and earned his PhD at the chair of software and systems engineering at the Technical University of Munich, specializing in software maintenance. Our second speaker is Bieth, who is a principal consultant at TNG. After earning her PhD applying machine learning methods to medical imaging, she joined TNG and has since excelled in various roles, including software engineering, product owner, and most recently as a chief technical director. And last but not least, our third speaker is Silbernagl, who is a senior consultant at TNG. He completed his PhD on mathematical optimizing power plant schedules before joining TNG, where then, in his role as a DevOps engineer and currently as a hands-on architect, he strives to modernize legacy applications, their surrounding infrastructures, and development processes. Maybe a little organizational note, we will have a Q&A session at the end, so please keep your questions till the end, and also for the remote participants, they can write their questions in the chat. We will take them at the end. And now, let's welcome our 3 speakers and dive into the unique security challenges, the innovative solutions, and invaluable lessons learned from this remarkable migration that they will share with us.
Yeah. Hello and welcome to our talk about migrating a security-first application to an in-house cloud. As CTO at Uniscon, I'm responsible for technological developments, our technological roadmap, also for orchestrating the different parts of our service, and also for the migration we are talking about. So this talk will begin with a short introduction to the context, so I'll explain the system to you the migration was about. Then we will continue with the timeline of our migration or the roadmap. Then we will explain the most important factors, success factors, and learnings from our migration on a technical and non-technical level, and then we'll conclude with some key takeaways and our main success factors. So what is this actually about? Uniscon, as a company, is your partner for highly secure content collaboration. Idgard is our product, and Idgard is a highly secure cloud platform based in Germany. More exact, Idgard is a software as a service solution for very secure file exchange and collaboration. It is also very easy to use. And wait a second. And we only serve business customers. That means our customers come from automotive, defense, health, law, finance, and also the public sector. And they use our system for exchanging highly sensitive documents, such as secret contracts or construction plans and the like. Something that really must not leak. By secure, however, we mean that even we, as providers of this service, are not able to access our customers' data in any way. So we're technically excluded from access to the exchanged data. In this context, we only know our customers' invoicing contacts and admin contacts for sending invoices. Of course, that's something important. And also for notifying our customers in case of maintenance work and these things. This level of security and privacy in our file exchange service is our highest commandment. And we take this responsibility, especially when it comes to security, very seriously. And what that means, we will see now on the next slide. our system is protected against unwanted and unauthorized access. This includes access by, for example, external attackers or other malicious entities, but also, of course, from state authorities, which is, if you host your systems, for example, in China or with the well-known hyperscalers in the US, different, right? However, we do not use, our service is particularly operator secure. That means, I already said that also our employees, so no one at Uniscon, is able to access our customers' data. This also includes metadata about our customers. However, we do not use end-to-end encryption for realizing that. We use a different technology which allows us to scan files for viruses, do PDF watermarking, and so on, and does not require our users to fiddle around with complicated key exchange mechanisms or other cryptographically introduced intricacies. Through our patented security concept, we achieve such a high data protection level that also regulated users from finance, law, and health are allowed to Idgard as software as a service. The system works as follows. Customers upload files via TLS encrypted connection, and then TLS is terminated in our high security area depicted as this green cloud up there. There, files can be scanned for viruses and so on, and they then are re-encrypted with file-specific keys for persistent storage. So there is also no master key or whatsoever. The security comes now from the fact that we, and of course no one else, has access to this high security zone, and we ensure this by no SSH access or anything the like in this green area. There are and were never admin accounts or the like, and everything's automated. Deployments, operations, and we have our own hardware. The hardware is secured by our patented sealed cloud technology from physical access then. So it's pretty secure. Now, that's a little bit of a different view on the system. Our service consists of the software part, the upper part, the tip of the iceberg, which contains functionality for file sharing, such as data rooms, privacy boxes, and the like, but also our encryption logic, and so on. The second part of the solution is not representable in software alone. Or let me put it like that, a system like that is not realizable in software alone. And therefore, we have the underlying hardware in our hands. And this is pretty interesting with us because the tech stack at Uniscon starts with cold, fenced concrete in a high-security data center. Within it, our own racks with special security measures and our own hardware, such as network equipment and servers, are protected from physical access. On this runs then our operator secure cloud platform, the sealed cloud. There we host our Kubernetes cluster, databases, backups, storage, and so on in our high-performance hardware. This representation is admittedly a little bit unfair to the software engineers now, because it is pretty complex what happens in the tip of the iceberg, but today we're focusing on what lies beneath the waterline, the sealed cloud. So hardware needs to be upgraded anyways on a regular basis, right? There are end-of-life times, things like that. And when our last end-of-life cycle came, we decided to take that opportunity to change a lot more. So we changed our data center provider, and we also changed our platform. So we did this migration of our security-first file exchange platform to stay up to date with state-of-the-art technology to sustainably ensure our security, reliability, and performance standards. However, when you want to upgrade infrastructure, long-running contracts are involved. You also need to get your hardware delivered, things like that. This is why the steps need to be planned pretty carefully. And of course, this imposes hard deadlines, really hard deadlines. So the challenge was, how can we migrate this lower part of the iceberg, the sealed cloud, in time? And how we did that will now be presented by Marie and Matthias.
Thank you, Sebastian. So just a caveat before I start going into more details, we will not get very much into the hardware. It will be mostly about the software and the platform. So like Sebastian said, the most important challenge was how do we meet our deadline? So let's look at the roadmap first. So you have to remember, I won't talk about it in detail, but we had hardware as well as software, and so this was a long project. You have to include the tenders, the contract, the delivery time, all of that into the project. So we had the project start mid-2021 with planning, in particular for the hardware, and we had a hard deadline end of 2023 where our existing data center was not going to be available anymore, so we had to have migrated to the new one. So in a perfect world, we would have ordered our hardware somewhere end of 2021 and start setting it up mid-2022 and be finished with it sometimes beginning of 2023. And that would leave us lots and lots of time to deploy our software on there, test it, fix any issues, and go live before the hard deadline. So if you believe that's going to work, what you can do is you fork your application at some point and you start adapting it to your new hardware, your new platform. And as soon as your hardware is there, you deploy your platform on it, you deploy your software, and well, I mean, it's expected at this point you have some bugs, right, or some issues, and you fix them. And in the plan here, well, we had more than 6 months to fix them, and this was going to work, and we were going to be live in time. What's not on the slide here is you have to remember when you fork your application, feature development doesn't stop, right? So you have some overheads of every feature you have to develop for your running application, but you also have to keep the forked one up to date, and you have to test your feature twice, right, in each of the applications. So that's overhead on top of the rest. Now, we already knew beginning of 2022 there were going to be issues with the plan because there were supply chain issues. So our hardware was going to come later than planned. So if we had stuck with our plan here of let's do a fork, then towards the end of 2023, our hardware would be there and we would be, for the first time, ready to deploy our software on it with the platform. And then we would realize, whoops, and there's issues. Except in this case here, we had only then like 6 weeks to actually solve these issues, and these even including Christmas. So at that point, we would have had 2 choices, and either we went live with lots of issues, or we didn't go live at all within the deadline, and that was not an option. So this would have been a very bad plan. Luckily, we did not actually follow this plan. Instead, what we did was we split the migration. So we took basically the most risky topics for us. These were the containerization and the storage migration, and we implemented them way before actually going into the new data center. So that means the main risks were already out of the way early. They were deployed in production in the old hardware, old data center. And when it actually came to deploying the software in the new infrastructure, of course, we still had some issues to fix, but there were few of them. This approach worked for us. I mean, we went live in time, but it also has drawbacks. In particular, for the containerization, since we deployed it already in the old data center, this meant lots of changes to our platform. So this was overhead effort that we had to incur. And the second thing was about the storage migration. Because our new hardware wasn't there yet, we couldn't actually use it for the storage, right? So the original plan had been that we would migrate to our own storage, but this wasn't possible. This was constrained by the timeline, and so we had to migrate to a storage provided by the new data center and managed by them as well. Now, security-wise, this is not an issue because we always ever only store things that are encrypted, so no one can actually read them, but this wasn't the plan. And so if we actually do want to migrate to our own storage in the future, this is extra effort. Nonetheless, we believe that this was actually the major factor that made us successful with our deadline. So let's look at how things actually went. So we had our project start mid-2021, started planning the hardware, ordering it at some point, and then in December 2022, we still didn't have much hardware, but our containerization was done in the old data center. So at that point, we had our application fully Dockerized, running in production already. The next topic was the storage migration, We did that mid-2023, and at that point, our whole storage was running already in the new storage provided by the new data center provider, and so that topic was also completely done. And then, quite a bit later, we got some hardware, and then our hardware was actually done in October 2023, which of course is pretty close to the deadline, right? Nonetheless, we actually went live 4 weeks later, so in mid-November 2023. So we just had 4 weeks between the time where our infrastructure was finished and the time we actually went live. And of course, yes, there were issues to fix at that point, but they were not that important ones, and we were always very confident that this was going to work. We basically had the time to fix them, and this was also the case. And we even went live with pretty good quality because we only had one somewhat bigger issue in the weeks after the go live. And so I want to talk about the second factor that was very important for us here, that is we only ever implemented the minimal solution. So let's take an analogy. If your goal is to stay awake, you can use both coffee machines on this slide, right? Now, if you use the bottom one, your coffee might actually taste better, but that's not your goal. That's just a bonus. And that was the same for us with the migration. So Sebastian already stated our goals. We wanted to open doors for the future. We wanted to have a security that was at least as good as what we had until now, and a stability that was at least as good. And that was the minimal goal. And we pretty early on realized that to actually achieve that within the deadline, we had to stick to the minimal solution and keep the scope very narrow. So how did we do that? Well, with several teams, we actually went regularly, or with all the teams, we regularly went through the backlog and looked at all the topics and wondered, hey, do we really need that from the start? And if not, then we postponed it to after the migration. And here, what really made it work is we had the clear commitment to actually working on the stuff that was postponed. So everyone knew if they say, well, no, we don't need it now, that doesn't mean it disappears, right? It means we will work on it, but later. And so everyone felt like they could give an honest assessment of whether we needed things or not. And we didn't have this trap of, well, if we don't do it now, we'll never do it, right? So I should say yes. So all in all, this was also very important, and we did go live within the given deadline. So now let's look into more detail how this worked for the storage migration. So also for the storage migration, we had our non-negotiable goals. There were other things we would have liked to do. We didn't achieve all the nice-to-haves, but we did achieve all the minimal goals. And the first one was, we wanted to migrate all the data correctly. Idgard is a data exchange platform, so this was pretty important. But we also wanted to have a proof that everything was correct at the time of switch. The second thing is we wanted to have a performance that was at least as good as before, and a redundancy of the data that was at least as good as before. How did we do it step by step? We first took a look at our system, and, this is just a sketch, obviously, but we realized we had a number of services all accessing our storage, all with different code. So there was no unified code for accessing the storage. So the first thing we did is we introduced an abstraction layer by writing a storage access library, decoupling the application from the storage. And we already did that for the old storage as well, and we deployed it, introduced it to all the services, and this went live one service at a time into the old production already. So after all of these went live, we had all our services still accessing the old storage, but all with the same code. And that gave us the confidence that actually our library had all the operations it needed and the right interface for it to work with the application. We also, however, implemented this library with the new storage technology, and we used it in our migration tool. So once we had our migration tool running, it was copying data from the old storage to the new storage, and also deleting data that wasn't needed anymore. And it was very important here, actually, that we did use this very same storage library, because we did realize at that point that in some rare cases, it was wrong. We had the bug, and storage data was written wrongly to the storage. So we could, at this point, correct it, and no customer impact whatsoever. So this went on for a few months, and then at some point, our data was fully migrated to the new storage, and we had all the administrative checks we wanted to have, and we could actually switch. So we had a planned downtime, We changed the configuration of our applications, and they accessed only the new storage at this point. And at this point, we also had our check that everything had been correctly migrated, and we had our proof. Now, like I said, data is quite important, right? So we don't want to lose any, it's customer data. And so the best defense here is don't trust anyone. Point one for us was do not trust your storage provider. For us, it was a third party. And so to check our data integrity, we had checksums. And with this new storage library, this is actually one little improvement we did. We introduced an audit log of all the application accesses to the storage. So every write, every delete, every read was logged into this audit log. And so if something would happen and some data would be, well, missing, corrupted, whatever, we would have a trace of did that come from the applications or not. The second thing is we introduced, or we have a self-hosted backup. And the goal here is to minimize the potential impact of a catastrophic event at the storage provider. So this could be a larger outage, or actually equivalent for us, a ransomware attack where the storage becomes encrypted and therefore unavailable. And we have the self-hosted backup with a different technology than the main storage that we could then use to recover the data. The second thing you do not want to trust is your own applications. There can always be a bug and your application is suddenly deleting stuff it shouldn't be deleting. There can always be an attack where your application or an application is taken over by some malicious actor, and you want to minimize the impact of that. You can't fully prevent it, but you want to minimize the impact. So what we did is, well, that's the basic rule, give minimal permissions to every application. So every application that only needed to read from the storage didn't get any write or delete permission. The second thing is we used versioning on our storage, which means that every operation is just a new version. A delete is also just a new version, and the actual data stays there for a few days more. And none of our applications could manage or even see the versions. They didn't have the permissions for that. Of course, we still had some credentials somewhere that we could have used to restore data from the versions if needed, but none of the applications had them. And the third important factor is our backup was fully isolated from all the applications. So the backup mechanism was completely in the background, nothing to do with the applications. So this, of course, offers added security, so that's good, but it has a cost, namely, if we actually needed to use this backup, it would take us at least a few hours to be up and running again. Now, we believe this is an acceptable trade-off because it's unlikely we need it, and it really brings added security. So what was the result of this storage migration? We had our planned 2 hours downtime for the final step, the final switch, and we actually had no complaints whatsoever afterwards, so no adverse customer impact, no storage incidents ever since, so we have a good stability, and we even improved a little bit the security and the data integrity on the way with our audit log. So that's for the storage migration. Now let's look at the application migration.
Thank you. Right. Same as with the storage, we try to keep the application migration as small as possible, and we split it up into many small steps, but we also try to push the production as quickly as possible. And of course, we did that to keep the risk low and also have enough time to fix any possible issues. Now, when I say keep it small, then why did we choose Kubernetes, as Sebastian said? Well, for that, we need to look at our old infrastructure. So this is an old worker node at Uniscon, and to guarantee the operator safety that Sebastian was talking about, what Uniscon did is they built custom images that boot using custom boot scripts and then run custom agents, which only expose a very limited number of commands to the operators, so that the operators never have access to the services directly. And you immediately see the issue, lots of custom here, right? So now, when Uniscon started with this, they were just quite ahead of their time, so these tools weren't generally available and they needed to build them themselves. However, of course, it's a lot of effort to maintain them, and I can tell you, nobody wants to maintain a boot script in particular. So when we switched to, actually the nice thing was that these this approach here translates quite nicely to Kubernetes, and by migrating, we were actually able to get rid of all the custom components. So now we use Fedora CoreOS, which is a minimal operating system aimed at running containers. We use the standard image, standard boot script, and on top of that, we use the Rancher agent and the Kubernetes agent, kubelet. And of course, the important question now is, can we still restrict these commands well enough? The answer is yes, but I'm going to go into that later. So now that we know the goal, what did we actually migrate? So Idgard is a classic web application. It has the standard service-oriented architecture, so you just have a set of services working together, which sit behind a reverse proxy and on top of some storage and databases. And now, I mean, in a typical cloud migration, let's just assume we go to the public cloud, how would you move this in an iterative way? Well, assuming that the environment is already ready, you would just set up some networking magic here on a high level, right? And then you would move over the services one by one. But remember, right, the environment was not ready up until very late to the actual deadline. So this approach wasn't feasible. We couldn't go service by service. We needed to go topic by topic instead. Now of course, with Kubernetes, there's a vast number of topics that you can consider. However, you only need to consider 3 topics to get started. The first one is containerization. Well, of course, Kubernetes is not running virtual machines, it runs Docker containers. The second one is ingress and networking, which is abstracted away in Kubernetes. And the third one is deployments, which are also quite different. There's another topic, usually persistence, but due to the security requirements at the Uniscon, the Idgard services already had fully externalized storage, and we already saw how that was migrated. So we didn't need to consider that. So let's have a look at all of these 3 topics here. So for the containerization, quite conveniently, when we started the migration, we already had some Docker images for local development, and they were full of workarounds, and they were quite far away from production, so we couldn't directly use them. However, they were good enough to create a first rough prototype, and we deployed that to a managed Kubernetes cluster in the Google Cloud. And now, starting from that, we just rewrote these images group by group. And here the great thing was actually that, again, due to the operator safety, Uniscon already had a fully automated node image build, fully automated deployments, externalized configuration. So basically, what you would now call infrastructure as code. And we were able to reuse quite a lot of that automation here for our Docker images. And that was great on one hand, because it gave us a lot of confidence, because the directory structure and the configuration in those images was actually pretty exactly the same as the one in production, so the step was really small. On the other hand, of course, if you do it like this, you will not end up with best practice Docker images. But that was not the point here, right? The point was to keep it minimal without reducing security, of course. So once we had the first group ready, we needed to move it to production, and for that we needed to build a new node image, and we chose Docker Compose for that. And again, we tried to keep this step as small as possible. So for example, we disabled the process and network isolation of Docker. And that turned out to be quite important, because during testing of the services, we noticed that under heavy load, the network behavior of the services was actually pretty bad. And so we eventually found out that we missed some setting on the node image itself, and we fixed that. Now, had we used the standard settings for Docker, so had we used the Docker network layer, I think you can all agree with me that that would have been the prime suspect, and probably we would have wasted lots of time debugging that first. Right, and once we solved all the issues, well, we moved the first group of services to production. And we just continued like that. Of course, we had more groups, until in the end, we had this fully Dockerized production environment. Now, of course, this took quite some effort, building this here. And especially we have always had to pay attention that we didn't go overboard and build some kind of Kubernetes-like environment here, right? But we still think that this was very worth it because we got 3 things out of it. Like the first thing was that now our prototype, so the thing that we want to deploy after the migration, our prototype here was much closer to production. The second thing was that we noticed lots of issues while rolling these out and operating these services, and we had plenty of time to fix all of the issues. And the last advantage was that we also gained lots of experience here with the migration. So at this point, we actually were able to split up the other 2 topics up in issues. So we really knew all of the things that we still needed to do until the end of the migration. So let's head into the second topic, the ingress and networking. So again, I'm showing here the old setup that was running in production, and here the new setup for after the migration. And as I said before, right, we had a reverse proxy setup built on Nginx, and this, of course, over time accumulated quite some configuration and also quite some special cases. So we had here some direct routing, for example, that went around the reverse proxy, and some custom routing between the services. Now, we didn't want to move that as is to Kubernetes. That would have been fighting Kubernetes. But we still wanted to keep it small, so what we chose to do was we chose to use the same software stack. And this was great because Ingress Nginx here offers lots of custom options that match, that corresponded directly to our old configuration. And so we were able to translate most of the configuration directly over into these Ingress objects. And we also got rid of the direct routing and of the custom routing here. They just didn't fit with this Ingress approach. Of course, that's not something that you want to do in a greenfield project because this couples you tightly to this Ingress Nginx implementation. But we were already coupled to Nginx before, and so we decided that the right point to think about that was after the successful migration. And so at this point, we did the same as before with the containerization. We translated the configuration back, and we got rid of these special cases. Or at least that's what I'd like to tell you, because actually, we thought it would be convenient and not a big problem to just leave the custom routing in. That was a mistake. And it was never a big risk, right? But in retrospect, it just caused confusion and extra effort so much that it didn't pay off. So what I'm telling you here is really stay diligent, keep the discrepancies to an absolute minimum. So that was it about the networking. So let's head to deployment. For the deployment, we quickly noticed that there wasn't any way of gaining the appropriate security without going fully Kubernetes native. So that's exactly what we did. So what we do is, during cluster bootstrap, we start up an Argo CD instance. That's a popular GitOps tool. And this tool will then fetch the deployment configuration of our services and push it to the cluster. And that's how we do all of our deployments, all of our production changes. The operators have read access to the cluster, so to understand the state of the cluster and of the services, but they do not have write access. And in particular, we also disable the debug handlers, so you're not able to execute into the containers, for example. Now, this may sound a bit extreme, because like usually if you do GitOps, you still keep admin access for your operations team. And I was also a bit preoccupied about that. But now, after more than 7 months of running like this, I have to say that it's actually really great. Because if you do it like this, then you know that really every change to production goes through the deployment process. You can trust your Git repositories to match the cluster. So that's quite nice. And I mean, of course, this approach will not work for everyone, but still, I feel that it's generally advisable to look into it. And for me, I think the caveat here is that your services need to be reasonably well-behaved to do this. So, and that was the last technical topic. I hope this gave you a bit of an overview of the technical steps, but we still have some non-technical learnings.
Exactly. So we had some learnings along the way, and we find some of them actually important enough to share them with you as well. The first one was, thank you, that we had to manage expectations. So on day one after the migration, it was pretty far from cloud native. And this was according to plan, right? We knew we were building a minimal solution. And we got buy-in from the management for that from the start. Now, we still realized pretty early on that we had to regularly still communicate what was part of the migration, and much more importantly, what was not part of the migration. Because, I mean, there's all these promises, hey, the cloud can do this, the cloud can do that for you, and we were not going to have it on day one. We had to communicate that to management, but also communicate very tightly with the developers. And we really had this conversation many, many times. Hey, yes, you see these things, we would like to improve them. And of course, as a developer, I also think that I want something to be improved now, right? Not later, ideally. But still, we always had this conversation, do we need that on day one? And if the answer was no, we kept on focus, we wrote it down, and we postponed it. And the key word here is postpone, right? So if you do that, you need to have a plan. What do you do afterwards? And Matthias is going to explain one such plan.
Yeah, at the example of the deployment. So before the migration, we started down here, and the deployment was high effort. It required a full downtime, and it had a quite slow rollback. On top of that, it was complicated, so only a few people were able to do it. The operation changed that, the migration changed that quite a bit. So we reduced the effort a lot. Rollback is now also trivial, and actually, some of the services we were already able to roll them out without downtime, only some of them. But still, the deployment was complicated, so now only the migration team was able to do it. Shortly after the migration, we fixed that. So at that point, we streamlined it. So at that point, all the teams were able to perform a deployment, of course, with the appropriate management approval. And currently, we are working on making it a fully downtime-free deployment. For that, we need to distribute the sessions securely, and that for us is a bit harder than usual, right? Because again, due to the operator safety, we need to make sure that the operators cannot access the session store. And the nice thing here is that Kubernetes will help us to keep them safe. And the final goal, of course, is continuous deployment, but that's something for the future.
Another important point that we had was our decision process and documentation. So it may seem obvious, but I'm going to say it anyway. Every single decision should be written down. And it's not enough to actually just write the decision. You need to write the assumptions you made when you took this decision and the reasons. And why? I mean, it saves you, or it saved us, lots of time not rediscussing the decisions were already taken, but it still gave us the right basis so that if the assumptions actually changed, we could go back to our decisions and look, this has changed, we do need to rediscuss it. So this was great for us.
And the last and maybe most important decision was you need to have a dedicated team. Like in the beginning, the migration was done in the same team that also implemented customer features, was looking something like this. And well, of course, the customer features usually have an earlier deadline, so they get a higher priority. And this resulted just in slow progress, and the split focus also certainly didn't help. This changed dramatically once we got a dedicated team, so the speed improved a lot, and the focus, of course, as well. Now, this team was fully committed to the migration, and it had a fresh and separated backlog, which was really great for management, because now to understand the state of the migration, they only needed to look at that backlog. And this was also very important, especially during the later phases of the migration, like when the hardware was getting close to done, because there we needed tight coordinations with the other teams. So here it was really important. All in all, I think that without this dedicated team, we wouldn't have had a chance of implementing the migration in time and with sufficient quality.
All right. Now let's come to the key takeaways of our migration. So the most important success factors for us were a clear scope and bottom line that enabled us to manage expectations, but also, to sacrifice optionals along the way. Also doing things step by step and having structured discussions enabled us to not having to rediscuss things. And this way, we just could really know what we actually did in the end, and this reduced our own failure rate greatly. However, you still need a very dedicated and very skilled team. 2 of these people are here, and even more people are sitting in the audience, so thank you very much for doing that with us. So these factors in mind and with a very skilled team made this migration a success in the end, and now we have even better performance, we have easier operations, our security concepts are implemented more easily, and all in all, we managed to increase customer satisfaction. Thank you.
Thank you very much for this insightful talk. Do we have any questions from the audience? Otherwise, I will start with a question. You go first.
Thank you very much for your insights. Super interesting. So looking back at this whole process, what's the one thing you would like to tell past Marie in, 2021? What would you do differently with today's perspective?
So I think what we would do differently is probably have this dedicating team earlier, because theoretically our migration had already started, but the progress at the start was very, very slow to this mixed team, so we would actually split that earlier. What would definitely keep is this minimal solution. This was key factor number 1, I think.
I absolutely agree. So one of the most important things, or what was a little bit tight in the end, was the schedule, even though we planned everything. But this did impose a load on our team, which was okay, but not great. Let's put it like that. And I think if I did it again, I'd do things a little bit more slowly.
So some of the security features or measurements are in the Kubernetes settings, basically. So how do you deploy the Kubernetes cluster itself in a secure way so that nobody can mess up the options and disable the security settings?
That's a good point. It's actually something that we left out, right? Because it was for the platform, actually. Probably it would be best to give it to my 2 team members here. So essentially here we went back to the previous automatic node builds. So we still do, we use Fedora CoreOS, which allows you to deploy a configuration, again, from a Git repository, and which also allows you to, it is not changeable from that moment anymore. So basically how it works is the node boots up, fetches the secure image, fetches the configuration from your Git repository once, and then basically the node is sealed. That's how we make sure that nobody, and of course we also don't have the typical debugging or administration measures, so you just cannot connect to the node anymore. Either it comes up and works, or you need to go to your test environments and figure out what is wrong. But you cannot test on production or change anything there. Yes.
And of course, if someone plays around with the Git repository to change things, this undergoes review processes and several ICE principles and stuff like that. So we make sure that nothing happens there on a more on an organizational or process level then.
Yeah, thank you very much for the interesting talk. I guess in this environment where you completely prohibit the administrator access, then operating the system becomes harder and you have to rely more on metrics and logs and so on. But in your context, you also want to make sure that not too much information leaks in there. So how do you make sure that this happens?
That is indeed I mean, the boring answer is you really need, this is one of the things that you continuously need to keep in mind. So the whole team needs to keep it in mind and needs to make sure that no sensitive information exits our logging. And we regularly have this issue because, for example, just lately we were changing the email feature, and that would have been great to see the email address. Well, it was not possible in production, right? And so what we do is on the test environments where we have our own synthetic data, there we can log more. On production, so basically we need to, it's more effort, but we need to try to get the same error on the test environments and debug it there. That's essentially it.
Maybe one question from me. So you emphasized several times your focus on having a minimal solution. That means there were quite a few topics you probably had to leave out in order to postpone in order to meet your tight deadline. So which one of these have you worked on since? Which were the most urgent ones? That you basically worked on right after the deadline?
So we're, you see, our engineers have quality in mind, and they know and they want to have the things that they identified before the migration. They really want to have it, right? And they would be unhappy if we just did not do it, you know? These are broken promises. So indeed, we are working on a lot of these topics. We even did, for example, migrate database and stuff like that after the migration. So we do work that. The things that we sacrificed went into a backlog are prioritized there, and we are working on them steadily. It's not only good for our tech stack and our tech debt, it's also good for the team.
Measures, for example, you keep this team.
This is one positive effect, yes.
Nice. Well, if there are no further questions, thank you once again.